Alright, so I'm being asked to factor this completely. So first thing I look for is a greatest common monomial, which we don't have. So then I'm looking for a difference of squares, and although I do have a negative 13, so I do have a subtraction in one of the places, I still have the positive 36, so this cannot be a difference of squares. Could it be a square binomial? It might be, because 36 is a perfect square, and x to the fourth is a perfect square. So let's treat this as a square binomial. And a square binomial will have one set of parentheses, one binomial, and it'll be squared. So what is the square root of x to the fourth? X squared. Since this middle term is negative, it has to be negative. Square root of 36 is 6. So then my linear term will be 2 times the a value times the b value, and hopefully that will equal negative 13. X squared. So 2 times x squared times negative 6, that's oh man, that's negative 12 x squared. These are not the same thing. Therefore, we don't have a difference of squares. So then I'm left to think about looking for a binomial pair of factors. So a binomial pair of factors will have two pairs of factors, and we know we're going to have x squared and x squared, because that's the only way to get x to the fourth. I mean, I guess we could have x to the fourth, or x to the third times x to the first, but that would make no sense. And so we're looking for factors of 36 that together have a sum of negative 13. So x squared minus 4 and 9. 4 times negative 4 times negative 9 is 36. Negative 4 times negative 9, or sorry, negative 4 plus negative 9 is negative 13. All right, so then I notice that I have x squared in both of these terms. That might be trouble, folks. So go back to my checklist. Do we have a difference of squares? Well, I have two perfect squares here. X squared and 4, they're both perfect squares. I have a difference. This is a difference of squares. So I'll write my two binomial parentheses there. I know I'll have one addition and one subtraction in a difference of squares. That's the only way to get a negative product. And so we have x plus 2 and x minus 2. Now looking at this one, since I do have the squared, is that a difference of squares too? Oh man, x squared is a perfect square, 9 is a perfect square, and we're subtracting them. That is a second difference of squares. Square root of x squared is x, square root of 9 is 3, and the only way to get a negative 9 is to multiply a negative and a positive together. And there's my answer.